Today I am going to derive wave equation for quantum harmonic oscillator. So suppose there is a particle which has total energy is half mv square plus half kx square. Okay, in macrostatic world, but in microscopic world, okay, that energy will be picker square by twice m plus half m omega square plus x square. Okay, to derive a wave equation for that particle, we just let's assume before that just we know that here square root of h cut by m omega has the dimensions of length and square root of m omega h cut has the dimension of momentum. Okay, we know this. So now let's assume an operator a cap which is equal to 1 upon root 2 square root of m omega by h cut x cap plus I p cap by square root of m omega h cut. Okay, x cap has dimensions of length and square root of m omega by h cut has dimensions of length inverse of dimensions of length, which means this is L and this is L inverse. Okay, similarly this has dimensions of momentum, okay, and this is dimension of inverse of momentum. So in short, okay, this operator has no dimensions. Now commutator of a dagger will be 1, okay, which you can show that with simple calculations. Here for a cap we can show that a cap can also be written as square root of twice m omega h cut into m omega x cap plus ip cap. Okay, now a dagger a will be 1 upon square root of twice m omega h cut square, okay, into m omega x cap plus I p cap into m omega cap minus I p cap. Okay, so this is will be simply twice m omega h cut. Okay, here we know that this is a scalar, but x cap is an operator, so it will operate, it won't get multiplied. So this is basically m omega x cap square. Okay, this will operate onto this, then minus I p cap, sorry, m omega x cap I p cap plus I p cap m omega x cap minus I square p cap square. So this will simply be twice m omega h cut. This is m omega x cut square. This I square is equal to minus 1, so will be p cap square. Now this will be I m omega, so x cap p cap minus p cap x cap. So the commutator of xp will be ih cut, which is x cap p cap minus p cap x cap. So we can write a dagger as 1 upon twice m omega h cut m omega, sorry, this will be square, okay, square m omega square x square plus p cap square. okay, and this will m omega h cut. Now if we rewrite this equation, we get a dagger a plus half h cut omega is equal to half m omega square x cap square plus p cap square by twice m, okay, which is basically the Hermitian we got. So we can simply write h cap is equal to a dagger plus half into h cross omega. Okay, this is the result. Okay, now to find the eigenstate of h, we mean eigenstate of h will be h acting on cation is equal to en acting on cation. So multiplying both sides by a dagger, we get, okay, first let's write the value of h, which is dagger plus half h cross omega acting on cation is equal to en acting on cation. Now multiplying by a dagger both sides, we get h cross omega a dagger a plus half a dagger acting on cation is equal to en a dagger acting on cation. And now we know that commutator of a dagger is equal to 1, which is equal to a dagger minus a dagger a. So a dagger a is equal to a dagger minus 1. So putting this value in this equation, then we get a dagger into a dagger minus 1 plus half a dagger acting on cation is equal to en a bar acting on cation. Okay, h cross omega would be here. Okay, simplifying this equation, we get h cross omega a dagger minus a dagger plus half a dagger acting on cation is equal to en a dagger acting on cation. So now h cross omega a dagger, and this term is minus, which will be acting on cation. Like taking this term on the right hand side, then we get a dagger plus half a dagger acting on cation is equal to en plus h cross omega a dagger acting on cation. Okay, here will be h cross omega. Okay, simplifying this equation, we get h cross omega into a dagger a plus half a dagger acting on cation is equal to en plus h cross omega a dagger acting on cation. So this is basically looks like a dagger is acting on cation. Okay, and this will be the n plus 1/5 state, means the initial energy was en. Okay, after the operator a dagger acted on the Hermitian, the energy has increased an amount of h cross omega. So basically a dagger is a raising operator. Similarly we can prove that a is a lowering operator. okay, which means okay, if there is a particle in a state of third, so by a particle in third excited state, so if the operator a dagger will act on it, okay, the particle will gain fourth excited state, and if a will act on it, the particle will be in second excited state. Okay, so far we know that h cross omega into a dagger a plus half acting on cat n is equal to en acting on cat n. So for ground state n is equal to 0, that equation will be h cross omega a dagger a plus half acting on zeroth state is equal to E naught acting on zeroth state. Okay, now a dagger acting on zeroth state, okay, what it will be, always a dagger into 0, so E naught will be h cross omega by 2. So for ground state, here the energy of the particle is not equal to 0, instead it is h cross omega by 2. So if we apply a raising operator on this particle for say ground state, so that after applying the operator, the energy of that particle will be h cross omega by 2 plus h cross omega, okay, which is increasing by h cross omega. We know that a is a lowering operator, so if so basically a acting on cat n will become cat of n minus 1. Okay, so let's assume that okay, we are going from nth state to n minus 1th state, okay, with some constant, let's say cn. So we know that bra and a dagger acting on cat n is equal to cn square, and this, okay, now the value of this will be 1, so cn square is basically and a dagger acting on cat n. Okay, now we are assuming that a dagger a is a number operator, capital N. Okay, so simply a dagger acting on cat n will be n acting on cat n. So simply we can write that modulus of cn square is equal to n. So cn is equal to square root of n. So basically the lowering operator, if we operate on this, then we get root n of n minus 1. Similarly for raising operator, we know that if it act on cat n, it will become n plus 1th state, so a dagger of n will be square root of n plus 1 acting on n plus 1. Okay, now suppose that particle has a wave function for n is equal to 0. For ground state, a wave function psi naught of x. So if an operator, let's say a lowering operator, act on this ground state, so the value that will be 0, which means acting on will be 0, but okay, the value of a is square root of m omega h cross x plus I p cap by square root of m omega h cross acting on sin 0x is equal to 0. Okay, this is basically m omega h cut x sin of x plus I by square root of m omega h cross. Now get the value of p cap is minus I h cut del x acting on sin of x is equal to 0. Okay, simplifying that equation, we get this sin naught by sin naught is equal to minus m omega by h cross x dx. Now assume that alpha square is equal to m omega by h cross. So, and by integrating this equation, we get d sin naught by sin naught is equal to minus alpha square integration x dx, which is ln sin naught is equal to minus alpha square x square by 2 plus some constant, let's say ln a. So sin naught of x will become minus a raised to minus half alpha square x square, and this wave function is normalized. So by applying some normalized equation, we get the value of constant a, which is equal to alpha square by pi raised to 1 by 4. So the wave function will be alpha square by pi raised to 1 by 4 e raised to minus half alpha square x square, where alpha square is equal to m omega by h cross. Okay, now from raising operator, we can write that a dagger acting on 0 will be 1 of 1. So basically 1 is equal to 1 upon 1. A dagger acting on 0 is equal to a dagger acting on 0. Now a dagger acting on first state will be root 2. This will be second state. This implies that second will be 1 upon the root 2 a dagger acting on 1, but this is basically 1 upon the root 2 into a dagger square acting on 0. Similarly, we can write this will be into 1 of that one. Okay. That for nth state, in terms of 0th state, nth state will be 1 upon square root of factorial a dagger raised to n acting on 0th state. Okay, so basically sin of x, this is a wave function for nth state will be 1 upon square root of n factorial a dagger raised to n acting on 0th state. So for the first state, from the raising operator, we get a dagger acting on sin out of x. Now a dagger is 1 upon root 2 square root of m omega by h cross x minus I p cap. This is p cap by square root of m omega h cross acting on 0th state. By solving this equation and putting the value of sin naught x, we get psi 1 x is equal to 4 by pi is to 1 by 4 alpha is to half alpha x e raised to minus half alpha square x square. So by raising operator, you can find a wave function for second excited state, third excited state, up to nth excited state.